Okay, so there's one topic I didn't get to in class, at least in the first lecture section, which was angular size and what a magnifying glass does. So we started this discussion by just asking the question, why does something up close look big and something far away look small? And here I have exactly that situation, a faraway object in your eye, and a nearby object in your eye. And you can see for the nearby object there's a larger image formed on the retina, and so that you perceive that object as being bigger. Alright, so how are we quantitative about that? Well, we just talk about the angular size. We draw two rays from the top and bottom of the image going through the center of the lens in your eye, which is really the lens and the cornea together, and those rays form some angle, and that angle theta just determines how big the image is on your retina and how large you perceive that object to be. And if that object is closer, that angle is bigger, and so it has a larger angular size. Alright, so that angular size, that angle theta, tells you how large the image is on your retina and how big it appears to be. So a key question is, what is the largest angular size for any object that's possible? Alright, so what is that maximum angular size? Well, it's just determined by that angle theta when you bring the object as close as you can bring it, which just means you bring it to your near point, and then that's the closest you can bring it and form a clear image on your retina. So here's a picture of that. So the object is off at the near point distance. Alright, so you bring it as close as you can. And the tangent of the angular size, well, it's just equal to the object distance over the near point distance because, well, that's just the opposite side of this triangle divided by the adjacent side of the triangle. When theta is small, and if you write it down in radians, then tangent theta is approximately equal to theta, and so we say that maximum angular size is just the object height over your near point distance. That's how big the object can look, the biggest it can look with the unaided eye. So what does a magnifying glass do for you? Well, it allows you to bring that object closer to your eye to increase the angular magnification. And it does that by forming a virtual image someplace else that your eye can see and form a clear image of on your retina. Alright, so here's a picture of how that works. There's a magnifying glass. Here's the object closer than your near point, the new angular magnification theta prime, and the virtual image that your eye treats as an object, which is formed by that magnifying glass. So I've simplified things here a bit compared to what was in the lectures previously. This is consistent with your book now, and I think more in line with the way people typically think about what a magnifying glass does and the way it's typically used. Alright, so typically, what you will do with a magnifying glass is put that object at the focal point of the lens. Alright, so this object distance here is really the focal length of that lens. If you think about the lens equation, that means that virtual image forms off at infinity. Of course, that doesn't really happen, but it forms very far away. What this means now is the new angular magnification, theta prime, is just the object height over the object distance, which is f, the focal length of the magnifying glass. If you compare that to your unaided eye, that angular magnification was the object height over the near point distance. And so the ratio of the two, which is the angular magnification, is theta prime over theta, or the near point distance over the focal length of the lens. So the smaller the focal length of that magnifying glass, the more curvy it is, the larger the angular magnification, and the larger the image is of that object that you see.